Good afternoon, everyone. Welcome to this afternoon's IIRSM Southwest Branch webinar. And I have the pleasure of introducing Adrian Eccles, who's the Technical Product Manager for Trolex. Adrian has over 25 years in the PPE industry, with experience working in distribution, originally for Arco, and then working at PPE manufacturers MSA, Uvex, and now Trolex. Before I hand over to Adrian, though, I would just like to give a quick shout out to the Southwest Branch. We are looking for volunteers, and if you are interested, please drop Julie an email, or alternatively seek us out through the main IIRSM website. Yeah, please do. It's good fun. I'm a member, and yeah, we are looking for volunteers. It's definitely worth joining up to. So, Adrian, over to you. Thank you for joining us this afternoon. We are looking forward to this webinar. Thank you.
Thank you. Good afternoon, everybody. Throughout this, if you have any questions, like Simon said, please add them into the questions, or if you want to contact me independently at the end, please feel free to do so. Simon will be able to share my contact details, either mobile number or email address, and any questions are welcome. And just on here, before I go into the presentation, any sort of stats and facts or figures are UK based. So if anybody's outside the UK, this is just UK based information, but the whole topic is global and refers to both home and work life as well. So any questions throughout, just please shout up on the questions, or if you want to do it directly, that's more than welcome. So let's have a look at real-time monitoring. So what is it? What does it do? What can it not do? Hopefully my slide has just progressed, fingers crossed. So we're going to look at scale of dust in the workplace exposure. I was doing one of these talks with an IIRSM group, and one of the ladies on the in the audience had just had some new kitchen worktops fitted. And so we think of this as dust exposure being in the workplace. The kitchen fitter had to do an adjustment on her worktops at the corner joint, and they just went out to their van and came back with an angle grinder and with a cutting disc on it, just to cut it in her brand new fitted kitchen. So she's there with a house pro person thinking about all the dust over her brand new kitchen, and B, a health and safety professional thinking, you're going to chuck a hell of a lot of dust out into my kitchen where I and my family live, and made them stop, get extraction, get suppression. And when she was talking to the fitter, he's just like, well, I always do it like this. And that's probably a common phrase that we all hear when talking about safety. I've always done it this way. My greatest response to that is when people say it. We all used to live in caves, and I don't think anybody on this call will be living in the cave at the moment. So we move on, we develop, we grow, we learn new skills, we learn how to protect ourselves better. So I'm going to go through that. We'll have a brief look at silica, because silica, probably after asbestos, is the most dangerous dust out there. It's much more common than asbestos, which really throws a different mindset into it. We'll look at real-time monitoring, how that links in with the hierarchy of control, what it can do, how it can help you with the other points in the hierarchy of control. And again, we'll go through what it can't do due to technology or legislative constraints on there. And as I mentioned before, questions are welcome if you want to do it at the end or throughout, and I'll try and answer questions at the end. But to try and get everybody involved, there's two pictures, A and B. Hopefully you can see those. The one B is probably something we all see when we're driving. You get a council contractor cutting a curbstone, and we see various levels of protection of RPE, even PPE. You see them doing the technical grimace, as I like to call it, when they've got one eye partially open, squinting, trying to keep the dust out of the eye, and also holding the breath so they don't get dust in the mouth. So that's image B. Image A is our test lab at our factory. So we have a laboratory where we test our units. So if you can, and we'll see if this technically works, so bear with me if it doesn't, if you could just, in the question point, say which you think is the most dangerous, A or B, or a reason why you can't comment on which is the most dangerous, whether it's bad quality photo, whether it's too little information, or a reason for that. And we'll just give this 30 seconds if you can put that in the questions, and I'll try and jump into Simon to see some answers. So hopefully this will work, but if it doesn't, please bear with me. So question, image A or B, or which do you think is the most dangerous level of dust within them? So we just got 30 seconds, so I'll press the wrong button on my watch. About 15 more seconds. It is a little bit of a trap as well, so if you're there thinking, I don't want to look a fool, this is just for more of a discussion point and a thinking point on why the subject is important.
I haven't seen anything come through yet, Adrian, but I would go for B there, looking at those two pictures.
Okay.
I would go for B too.
All right, we'll go with those two answers of B, and well, if technically wise, if other people answered, if you got different opinions. So typically
looks like we've got another B as well, so that's 3 Bs.
Okay, so you can see a lot of dust there, and with dust inhalation, we talk about the particle size of it. So human hair is 60 microns, and the dangerous dust that can get into the bottom of your lungs is 4.25 microns and below. So often when you see a lot of dust as in image B, it's the larger particles. There will be smaller particles within that, but this is often the big dust that you can see first of all. The harmful dust you can't see with a naked human eye. So whereas in image A, we have the particle dust that size that is dangerous, and we also have silica content in there that is dangerous. So I don't know which is the most dangerous because image B is a stock photo. Image A is our test lab, and I know how much silica dust we put in there. But this is the point. So often you can't see the dangerous dust, or you don't know the content of the dust. So this is why monitoring is really important, so we can do that. So those who answered question B, you're not wrong. Image B, sorry. Those who answered image A, you're not wrong. It's just that both we need more information. So it's just to get people thinking about dust, what is the issue and what is the more dangerous bit of it. So these are figures related to the UK. It's very hard to get information out there, but 450,000 cases of occupational lung disease in the UK. So that's a hell of a lot of people affected. If we think about slips, trips and falls, the numbers are lower, deaths are much, much lower. 17,000 new occupational cases of lung disease each year. And I live in an old mining town, so you think when the mines shut in the 80s, lung disease was a huge factor in the mining communities. So you'd sort of think that with modern health and safety, you'd see that dropping down, but actually it's still not. Construction workers, that's a really high number there at the bottom. If any of you work in a construction business, I've got friends or relatives who do. Most major construction sites now, very good health and safety in there. You'll have to wear your high vis, you'll have to wear full length sleeves, you'll wear a helmet, you'll wear eye protection, wear gloves of the right standard for the applications. A lot of them are doing fit testing for the RPE, and they've got great vehicle movement control and to do traffic management really well, and not the big projects you go to. And that's where you then see the preventable occupational disease is still the biggest factor that's more likely to kill them from traffic management incidents or fall from height. But every construction site you go to, and they've got really good scaffolding or really good traffic management. So if you are involved in that industry or you've got friends and relatives, just get them to think about what they do about protecting themselves from dust. So it really is, as you can see with those numbers, a big thing. And I'm sure we've all got out of bed in the middle of the night. I'm a man of a certain age, so I get out of bed in the middle of the night and I'll stub my toe on the bed and I'll say a few naughty words. And so we've all stubbed our toe and we get that impact straight away. And we know about it because we feel it. We've all probably been cooking something in the kitchen and just cut our finger. And again, you'll feel it and you may see a bit of blood and have to put a plaster on. And that's instant. You see that. And the same in the workplace. If you drop something on your foot, unless you've got a metatarsal and a steel toe cap, you'll feel it. And the same with a cut injury in the workplace. You'll see the blood, so you know it's there. But with lung disease and also hearing loss, you don't see it, and it's a gradual build-up over years and years and years, which makes it harder to see. And that's where it's more dangerous in the long term, because you sort of accept it's not causing you immediate harm or discomfort, so you accept it as being okay. So just more to people to question that, is that dust level okay? Is this going to cause me long-term harm? That last slide, it mentioned about the level of factor of 100 more times likely to die of lung disease or occupational disease in construction. But it's not just construction. Dust in flour mills, so bakeries, flour mills, even the likes of the Greggs factory, if depending on the dust levels in there, Wolverton's, etc., these major factories, occupational exposure to flour is bad to us at high level. You think something as innocuous as flour, I'm sure a lot of us have had a sandwich for lunchtime. Would you think that's dangerous in a manufacturing state? But it's because it's an airborne dust that can, in the right size particle size, get into the bottom of the lungs and cause damage to us. It's a real problem. So even if you're not working in what you may think is a dirty environment, such as metal processing, construction, aggregates, road workers, etc., like that, even something as innocuous as flour in the right particle size and concentrations is bad for our lungs. So it's just a bit of an eye-opener to other types of work environments. We talk about particle size. I mentioned before the human hair size, and then how the body's got its own defenses. So again, I mentioned I'm a man of a certain age, so my nasal hair is doing a great job at preventing lots of big particles going through my nose. The mucus in our throat also traps larger particles, and our cough reflex helps get rid of them. But then the bigger particles, 10 micron and below, can get into our lungs, and the small ones, 4.25 and below microns, can go right into the bottom of the lungs when they just can't be removed. And this is where you can get a chronic disease from there. And you can see some of those that can give you just real problems there. Welding fumes, really hard to control a welding fume. In most places you go and see welders taking place, they've got a face shield and a powered respirator, but then the other people in that building who are either working on a different section or supplying components to the welder, they're often unprotected. So they're breathing in the exhaust from the welding if it's not vented and extracted properly. But how do we know if it, excuse me, if it is, if we can't see it? Asbestos, most people know about asbestos and the dangers of it. It's quite alarming in some ways when you hear of what used to happen to it and how it's all over any sort of building. Pre-80s is going to have a really high chance of it being there. At the start, Simon mentioned I used to work for Arco, who are a major PPE distributor. Back in the 90s, we used to sell lots of asbestos gloves to the steelwork industry in Sheffield. And when it had to switch to an aramid fibre, when asbestos was finally outlawed in PPE, bizarrely, they complained that the new product wasn't as good. But when he explained the dangers to them, most accepted it, but some still wanted to have it, saying it was the best thing for heat protection. So some of the products we've used, so asbestos is easy to eliminate, because we're not allowed to manufacture anything with it anymore, but silica, welding fume, wood dust, all happening in lots of different environments. Here's just a cross section of a human hair, so you can see that 60 micron there, and then you just look at the small particles, PM10, that can end up in your lung, and PM2.5, which can get to the bottom of your lung. So this is why they're impossible to see with the human eye. So if you go back to image B and you could see a lot of dust, that'll be the bigger particles that you can see. These two small ones you can't see by the human eye. You can either see it under really, really bright light. You know, when you're in a building and you've just got a ray of light coming in and you can see the dust floating in the air, something like that, or a high powered torch. In a dark environment, you can see it all with monitoring technologies. So this is the sort of size of particles are, and because they're so small, they can get past our human defenses and then cause issue. So I mentioned wood dust, welding fume, asbestos, and silica. Silica causes silicosis, and silica is a really, really common substance. It's found in most rocks in different concentrations, clays, granites, going back to the previous comment about the kitchen fitter. And it's used in anything. So if you're having any construction work done at home, if you have any construction work done in your workplace, is the dust levels at the construction affecting your health? Are they putting you at risk? So it could be something like a granite or stone, artificial stone worktop, or you could be having a new concrete pad put in to expand your factory, your warehouse, and your workplace. So this is where you can have high levels of silica. And when you look at some of these concentrations, so concrete can have between 25% to 70% silica. And so if you are having some existing work redone on your building, and they're breaking the existing concrete to tie the new extension into it to expose the reinforcement to tie them together, that dust level could have up to 70% silica. Even having, say, the Sky engineer come and he or she is drilling through your wall at home through the mortar or the brick, that can have a high level of silica in the mortar and brick. Admittedly, you've got to be exposed regular, but little things like that. So if you have a maintenance team in your business and they're doing these tasks regularly, or you work in a manufacturing environment with any stone, concrete, mortar, etc., this is where you can see a long-term build-up that can affect the worker's lungs. So silicosis, which comes from inhalation of silica and causing damage to the lungs, it's the most common occupational lung disease in the world. And when you look at how many people affected, forces 50 million. This third point is really something the whole industry needs to try and highlight. If you were to walk into your town centre with a clipboard on Saturday morning and ask 100 people if they'd heard of asbestos, I'm guessing 90 of them will say yes. And then if you was asked the same 100 people if you heard of silica, I'm guessing 10 of them would say yes. But then when you look at it's the most common chronic lung disease in the world, I think there needs to be a whole education to tell people how dangerous it is. And if you just refer back to the previous slide, if we think of concrete, which can have up to 70% silica content, it's easy to see how people can be affected by it, even if it's a secondary exposure. So you may not be working in a construction, but if you're next to a long-term construction project and there's lots of dust blowing into your garden, you're sat there in the evenings or in the days, you can get secondary exposure to it. So, and the same goes near aggregate or quarrying applications. So when we think about the exposure level for silica, respirable crystalline silica, to give it its full terminology, that dot is the current allowed exposure level. So it's roughly the size of the O on the 1 penny piece. So if anybody's got a penny, you can easily think how small a penny is, the size of your thumbnail, just a tiny dot on there. So if you go back to right at the start, picture B, and that curbstone, if it was concrete, it was actually a stone one from memory. If it was concrete curbstone, that could have 70% silica content. So it's really easy to see when you see that tiny dot as your daily exposure limit, how you could be so far over that without the right protection. So if you are working in cutting curbstone, make sure you've got the right suppression, extraction, right RPE, that's fit, test and trained for it, because it is only a tiny, tiny amount. And the UK is currently behind lots of places in the world. So our exposure level, allowed level, is 0.1 milligrams. Australia is 0.05, Canada 0.05, US 0.05. I think Belgium from memory is 0.025. Australia looking to go down to 0.025. Certain states in America are looking to lower it to 0.025. There is I'll come on to it later about the UK. We are looking to lower ours. But it's a tiny, sorry, if you go back to that, and Australia is half of that. So it's a tiny amount in lots of the other industrialized nations of the world. So what does it do? It causes long-term health problems to your lungs by scarring the tissue in your lungs. My dad worked in a brick factory for just over 30 years. His initial role was working on the mixing plant, so he had to shovel in the right mix of sand, cement, special dolomite and chemicals, power stabilizers into this by hand. It was a hard manual job. He started there in the late 70s, so he had no RPE. In the early 90s, they did have some RPE, sort of a really, really basic disposable face mask. And he used to wear about 3 or 4 in one go, but it was nothing like what we have now. I can remember them being in the garage as a kid. But when he started in the 70s, it wasn't the knowledge. And when he came to his retirement, he was diagnosed with having COPD, so he's very limited lung effect. As he got a bit older in his retirement, we had to install a second handrail up the stairs, because going up the stairs, he had to stop because he just didn't have the lung capacity to keep going. He had to get a mobility scooter because he couldn't walk because his lung capacity wasn't there. And so for his plans for the proud working man, for a happy retirement, lots of holidays and lots of looking after the grandkids and playing football with the grandkids, etc., he wasn't able to do that. So as well as silicosis in really acute and chronic stages, killing people early, it can also really have a life-limiting effect. So if you think of somebody like my dad, or you may know people who are suffering and have to have oxygen, or who have to have mobility issues because of COPD, silicosis and things like that. So you don't see it straight away, so it's harder to act upon it, but it's where it builds up and builds up in your lungs and causes this long-term effect that, for example, my dad, it affects his retirement and an early death as well. There's 3 types of silicosis, basically depending on the level you've been exposed to. And there's been a few stories in Australia of really acute silicosis where some young men working in the kitchen worktops with an engineered stone worktop that has 94% silica, dying in their 30s. Australia are looking to ban this material, but other countries in the world aren't as advanced as Australia with it at the moment. So it's all 3 affect you. It's just at different levels of time taken to get to you and affect the body. This was an old example in America back in the 30s. They didn't at the time know the name for it, but they were hand digging and drilling and exploding a new tunnel. And 80% of the workers became ill, died, or walked off the job due to ill health within 6 months. And the rock was later found after testing to have a huge silica content in it, over 80%. And there would have been no ventilation like we have now in modern mines or tunnels. And it just shows that this has been around for a long time. Now, fingers crossed this video is going to work and you can hear the sound. If you can't hear the sound, I'll send a link afterwards so you can watch it. It's actually the image is actually more important than the sound. It shows how our body's natural defense works with silica and what our lungs do and how they wrap around the silica and bring it into the wall. So if you can't hear it for any reason, I will share the link with Simon and he can send it out afterwards. So if we do have a technical issue with sound, don't panic.
Silica. It's one of the most common substances on Earth. It can be found in materials like sand and rock, and building products like concrete and brick. When a worker cuts, grinds, or drills materials that contain silica, dangerous crystalline silica dust is released into the air. As the worker breathes, silica crystals flow into his mouth and nose and down the air passages deep into the lungs. The tiny crystals enter the small, fragile air sacs, where oxygen is absorbed into the blood. Immune system cells, called macrophages, engulf and try to dissolve the crystals, but they are unable to. Over time, more and more crystals build up inside the macrophage cells. The macrophages carry the silica into the walls of the lung, where they die. Scar tissue forms around the dead cells and spreads as more cells die. This damage can continue even after the exposure to silica stops. Eventually, so much scar tissue forms that the lungs can no longer function. For information on how to protect yourself from silica exposure, visit worksafebc.com.
So hopefully you heard the sound, or you could see on that video, the body's natural defense wraps around the silica in the lungs and then pulls it into the lung walls, and that's where it dies off and then causes that bit of the lungs to die. And it's a cumulative effect of this that has the effect over the years. So going back to image B at the start, you may think you're just going to do a shortcut on one curbstone or one operation, but that repeated exposure after years and years and years has a build-up where you can see so little quality is left in the lungs that the person really struggles to do anything that requires any effort and lung capacity. So it's very, very life limited in what they can do with a lung level as that is. There's a recent example of that. This Scottish stonemason, he'd been working on churches and old buildings for years and years and years, working with a chisel most of the time, but sometimes doing powered cutting. And even with a chisel, where you strike it, hammer and chisel, you do get some tiny fraction of dust coming off that you don't see. He'd had no protection from it. He's been awarded a huge amount, but if you search out and look at the link on there, he's having to live in a powered wheelchair now. He looks very, very ill and probably got a very short prognosis on his lifespan on there. On the bottom right there, that's in his 37, diagnosed with a year left to live. Also, the health and safety executive have been doing a lot of exposure on lung protection and the awareness of dust, etc. I mentioned earlier on when we had the slide with the penny, if you remember that, where it's a tiny dot. There was a report released early January by the APPG, All-Party Parliamentary Group. So it's a working group across all the different political parties. And they've tasked the HSE to lower the UK exposure level from 0.1 to 0.05. They've also tasked them to do greater awareness campaigns and also look at real-time monitoring and also some health benefits. So like I mentioned before, my dad was diagnosed with COPD, but there was never linked to his work environment to his COPD to look if it was silicosis or not. He was just diagnosed of having a poor lung capacity because of COPD. So that the cross-party group, the APPG, really want to look at it as a wholesome project to lower the level, to monitor for the level, raise awareness so people know how dangerous dust exposure is, and also do a 360 so the health service is reporting better, so we get better data coming through, and then that data can help look at how we protect people moving forward as well. So there's quite a bit of focus going on around dust exposure. So we spoke at the start of it about real-time monitoring and what can real-time monitoring do, and has anyone heard of real-time monitoring before? So one thing that a lot of us got now is a Ring doorbell. I know there's some other brands out there. So it's a real-time monitoring device. I was in my local pub a few weeks ago with my next door but one neighbour, and his phone starts buzzing with that ringtone, and he looks at his phone and he says a few naughty words and asks him what's the matter. And he shows me there's 3 lads stood on his doorstep with crates of beer. I said, what's the problem? He said, well, my son's supposed to be revising for his A-levels. So he picks up the phone, phone's Kian. I said, Kian, what are you doing? Revising, Dad, like I said I would be. Are you sure? Yeah. So he had a screenshot of the 3 lads on the doorstep, sent that through to his son. He says, oh, right. So real-time monitoring is different to what we're looking at, dust monitoring, but it's just an example. Real-time monitoring got live information. Another common one is a watch. A lot of us have got fancy watches that show how many steps we've done today. 8,943 for me so far. There's your heart rate, so we can get lots of information off our watches, or it's get text messages coming through or WhatsApp messages. So that real-time data is there and easy to hand. And one of the common one we've had for quite a lot of years is, would you think of driving anywhere without looking at the speedo? So, and also if you have driven today, can you remember if you was always adhering to the speed limit, or were you above it, were you below it? So having the information to be able to look at later on as well can help in a dust environment to see what you've done. So this is where real-time monitoring is very, very common in certain applications, but it's quite new to dust applications on how to protect workers. This unit is just one that counts the particles of silica going through it. It then displays the total silica content at the top. So this is showing 0.049 milligrams per meter cubed. The UK limit is currently 0.01. So if this was your workplace, then you are at a safe level. But could you then use this data to try and lower the level even further? Could you look at your filters, whether if you got extraction, whether they're being changed often enough, etc. And that is just showing total particles of dust per litre. So this is the data you can get from real-time monitoring units. And then going back to what I said about when you've been driving, this can give you the information on afterwards. So my teenage daughter's been driving a year, and so she has an app that shows her score and its acceleration, braking, and general driving. Supposedly it's to make the insurance cheaper, but she's got gold in every one, and they've not lowered the premium down that I've paid. So whether they just charge you more if you're bad and less if you keep it the same if you're good. That's again another example of real-time data. So this is our test lab. So this is section A. So you could see the blue here is a silica, respirable crystalline silica. And if you remember that the UK exposure level is 0.01 milligrams per meter cubed. When we was dosing that photo A, you can see we're getting to 8, so we're 80 times the exposure level. So that shows that photo A was very dangerous if you was working inside that booth. It is a sealed booth in our lab, but it doesn't look very dusty, but it had a huge amount of dust in there, but it's very, very small. So this blue dot here is the silica peak, and it's just over 8, so 80 plus times the UK exposure level. So it just shows you, if you remember back to picture A, it didn't look that dusty, but the dust that was there was very dangerous. And again, you can have this expressed in fancy graphs to help you with monitoring the workplace. You could look at here, why did we have a huge exposure on this day and what happened? It could be you have a different worker on shift. These could be trained workers in that application, and then you've got somebody in covering a different shift and they do something different that makes it a more dusty environment. So you can see that that maybe they need a bit of training on there. So when you look at the hierarchy of controls, elimination's a top one that we should all work for. But when you think of silica being common in so many rocks and stones and concrete and mortar, you can't eliminate it in the workplace. There's a big focus with the concrete companies of having carbon-free concrete, and that's a big focus for the environmental side. But for the health side, as of yet, it's impossible to have silica-free concrete. Could you substitute it if you're having a new construction and extension to the warehouse or your production? It'd be very hard to substitute a concrete floor. So that's again where you can't really see what's going on with any real way of changing it. Engineering controls, this is where real-time monitoring can work. So if you've got a task where somebody's cutting a stone, like in picture B, and you can then monitor the exposure level, you could then see if you've got extraction or whether you need to introduce extraction, or you could go for a water suppression to wet the dust so it can't go airborne. So this is where, between engineering controls and PPE, you can use real-time monitoring. Admin controls, it helps where you can see what each person's being controlled to. A lot of people in a dusty exposure will often go straight to PPE for a disposable P3 dust mask, the white ones, whichever brand you may or may have not seen or used. So disposable P3 dust mask has what's called an assigned protection factor of 20. So if you remember back to the exposure level for silica is 0.1 milligrams per meter cubed, and in our test booth it was 8 milligrams per meter cubed, so that's 80 times. So if you was working in that room, a P3 disposable mask isn't powerful enough, if that's the right word. You'd need to go to a full face powered respirator or something like that with a higher protection factor of 100 plus. So even though you may have your staff fit tested, even though you may be wearing a quality P3 disposable mask, if you then introduce real-time monitoring, you'd be able to see that it may not be suitable, may not be adequate for the task, that you may need to go to a higher level of RPE or engineering control to increase the extraction. You could introduce the extraction and everything's going fine, and then you could have a bird nesting in the outlet, and so your extraction could be making a lot of noise, but actually it's not venting off anywhere because the extraction's blocked somewhere, or the filter's blocked, or the bag's full. So by checking with real-time monitoring, you see for changes of what's going on. That's where it really fits in with a hierarchy control on there. So this is what's called gravimetric testing. So currently in COSH in the UK, this is referred to for what's referred to as regular testing for a dusty exposure. So if you're working in any environment where you've got 10 milligrams of dust per meter cubed that you don't know, or you've got anything that's dangerous such as silica, you have to do this. And it's defined at regular intervals, which is often considered at 12 to 14 months. But going back to the picture of the speedo of the car, would you only want to look at your car speedo every 12 months? Would you want to be seeing the data that's happening in real time so you know if your process has changed? If the weather is drier, are you getting more dust? If you've opened your building, warehouse or production doors in summer, are you then sucking in dust from somewhere and moving it somewhere else where you haven't got the extraction? So having real-time monitoring can give you that information straight away with any changes that are coming through. So that's the difference it can do compared to COSH. And part of the APPG report is for the HSE to introduce real-time monitoring into COSH. So if you were to read through COSH, it does reference this type of sampling, but the government are challenging the HSE to update it as technology has been around for a good few years now, and the HSE needs to focus on updating the COSH regs. These are just various reading lists on there, so if anyone wants to look at those, then please feel free. If anyone has any questions, Simon, I'm more than happy to answer, or if anyone wants to send them personally, Simon, feel free to share my email and phone number to everybody.
Brilliant. Thank you very much, Adrian. That was very informative. I do have a couple of questions. I got one for myself, actually. You mentioned Australia a couple of times in terms of particle size, what's acceptable to them. And there was, I can't remember what the other mention was, but it is, in your opinion, is Australia ahead of where we are in terms of dust monitoring and dust control?
Definitely. They've got a two huge focus because they've got such a large number of mines for different metals with the increase of people driving electric cars, lithium and things like that. Australia, they have a huge amount of mines exploring those precious metals. And then on the other side, that's a very, very dusty environment. And as you go into the centre of Australia, it's very dry and very dusty. So they know a lot about dust anyway. But they've also got a focus where they've done lots of health monitoring on people working with this artificial stone of kitchen worktops, and that's at 94% silica content. And so they are the most proactive in the world at the lead of controlling silica and dust in the workplace, and they are pushing it. So they're at 0.5 now. 0.05, sorry, and they're looking to go to 0.025. That's going through their legislation at the moment. They've introduced real-time monitoring. We had some funding a number of years ago from New South Wales government to develop a new unit, so they really are on top of it. We in the UK are lagging behind, which I don't really like to be that. Normally with most health and safety regs, we've been at the forefront of the world and we've been very, very good, but with dust monitoring and dust levels, we're a bit behind. So yeah, Australia are definitely ahead of us, as are Canada and the US. So it's not great to be behind the Aussies, especially coming up towards the Ashes.
I must admit, it's quite scary having listened to your presentation and knowing that even in recent weeks where I've come across road works or building works in the local area where you see the stone cutters and things like that being used, and the lack of dust control measures or control measures in place are not there. There's people are still covered in clouds of what I can only describe as stone dust, concrete dust.
And there's technology out there now to have on-tool extraction, or even just a simple pressurized sprayer just to wet the surface. You can have the tools now with water tanks, and people always say cost, but you can go to Wilco and get a pressurized sprayer for 10 quid and just wet the surface before you cut it, re-wet the surface as you're cutting it. So I'm not saying everybody's got to go out and spend hundreds of thousands. There is simple technology you can do to reduce exposure.
Yeah. I do have one question that's come in. If anybody has got any questions, please drop something in the comments box. But I do have one specific question that's come in via WhatsApp, as this particular member couldn't attend today. You may have already answered it on your sort of last section of the presentation, but I'll in case you haven't, I'll read it as I've got it here. So the question is, I've used a real-time device in the past, but which, if any of the real-time techniques are accepted by HSE as an alternative to gravimetric measurement, are any or others likely to be approved in the foreseeable future?
So we'll take current state at the moment. Current state, none are approved by the HSE in under COSH. So COSH has been around for a number of years, but if you now read and COSH is legislation. So if you read the HSE guidance notes, so there's like a guidance notes for stone workers and brick manufacturing, they do reference real-time monitoring in guidance notes. So, and going back to the APPG report, where the government are challenging the HSE to bring real-time monitoring into the regs. It will take time, and HSE doesn't move very quick, and to get legislation change like COSH will take time. That's why the HSER put it in their guidance notes, which they can update overnight.
Yeah.
And the best way of thinking about it, gravimetric you have to do to hit compliance. It's a legal requirement. Real-time monitoring is another tool in the toolbox to protect your workers. And having both will give you more information to help check your engineering controls are working, or B, see if you need to bring in new engineering controls to protect the staff. So if you as a business are thinking about doing it, it will be a good thing because you'll be ahead of the curve and it will come in. At the end of the day, if you have a dusty environment and you can have some data that helps you lower your exposure for your members of staff, it's a great thing. So people, when my dad worked in the 70s, it wasn't known about the dangers of dust, but it is known now. And so yes, I appreciate sometimes as a business, if you go to finance and say, I want to get this unit, why do you need that? Oh, it'd be nice to have. Do you legally need to have it? No, not at the moment.
You've had those conversations as well then?
Yes.
Okay.
Things, to me, personally, I'd love people to embrace monitoring as a way of protecting staff. But going back to that Scottish stonemason who was awarded £3.5 million compensation, those figures make staff finance listen as well.
Yes.
Yeah, I'd rather you wouldn't have to have that, but then just think this is a benefit of people's health. Let's do it and move forward.
Yeah,
but sometimes you need to have the stick with finance, don't you?
Okay, brilliant. Thank you. I don't think we've had any more questions come in. Can't see anything on the chat box there.
If anything through later on or anybody wants my details, please share, and I'm more than happy to answer or talk directly with anybody.
Yeah, and likewise, this recording of today's webinar is going to be on the IIRSM website, on YouTube channel, I should say, not website, on the YouTube channel. I'd just like to say a big thank you for Adrian for doing the presentation this afternoon. Really informative. I have seen this before, and I've still learned something new from having seen it the second time round. So thank you for that. And anybody that is in the Southwest who is a member and who would like to join the committee, but please get in touch through the usual channels, and yeah, we welcome you on board. I don't think there's anything else. Adrian, thank you very much again. Thank you all for joining us this afternoon. Julie, I don't think there's anything else to cover off, is there?
No, I don't think so. But if anybody does want Adrian's contact details or interested in joining the committee, just email branches@IIRSM.org and I will get back to you as soon as I can.
Brilliant, thank you.
And thank you, Adrian, for giving up your valuable time. We really do appreciate it.
Thank you.
Goodbye, everyone.
Thank you all. Bye-bye.